In this example, we have another navigation problem, and we're told that a ship sails 70 miles on a bearing of 20, then turns and sails 80 more miles on a bearing of 80. We're trying to find the resultant displacement vector as a distance. We're looking for the magnitude and the bearing, so what direction we would have to head to be on this resultant vector here. So remember that everything is measured, bearings are measured from north. So 20 degrees from north would be in the northeast direction. Then we're going to turn and we're going to go 80 degrees, which is a little bit shy of 90 from north, so still in that northeast direction. So we're going to primarily be up in that first quadrant. So just to make sure that I have enough room and to have a good clear drawing, I'm going to focus my compass more so just in that first quadrant here. So I'm going to call this northeast, southwest, but I just made my first quadrant a lot bigger just so I have plenty of room. So the first vector, again, is 20 degrees, and so that is 20 degrees clockwise from north. So something like that. And this is 70 miles. And I always recommend labeling that bearing so we know that that is 20 degrees. Every time you change directions, I want you to draw in a new compass, because now we're going to travel at 80 degrees. And so right here, due east would be 90, so 80 degrees will just be a little bit shy of that. And this time we're traveling 80 miles. And then this is 80 degrees. Now, whenever you draw these in, there's always going to be other pieces of information that you can find on your drawing that aren't explicitly given to you. And so what I mean by that is if we're traveling 80 degrees, I know that that's 10 degrees short of traveling perfectly east. So this little angle right here is 10 degrees. Well, from here, I know that this angle is 90, and this 20-degree angle is going to help us also. This north-south of this compass and this north-south of this compass are obviously going to be parallel. Well, this would then be a transversal, and so this angle and this angle will be congruent because they're alternate interior angles. So that angle is 20, this is 90, that's 10, so that tells me that this entire angle is 120 degrees. And that's helpful because now I have enough information to find other pieces of this triangle that we get from our resultant vector r. I have side, angle, side. So our goal is to first find the distance of this vector. And since I have side, angle, side, I'm going to set up and use the law of cosines. So I'll have the magnitude of vector r squared is 80 squared plus 70 squared minus 2 times 80 times 70 times the cosine of the angle in between them, which is 120 degrees. From here, once we simplify the right side and square root, we should get the magnitude of vector r to be about, and I think it ends up being exact, 130 miles. Okay, so now that we know this distance of the resultant vector, we need to know what bearing. So for instance, let's say that this ship sailed on this vector, and then for some reason stopped here, and we're at the starting point and needed to get to that ship quickly. This is the path that we would take, the direct connection. And so yes, the distance that we'd have to travel is important, but most importantly, we would need to know in what direction would we start. And so we're looking for the resultant vector's bearing. Well, I know this chunk of it's 20. This is the part that I'm unsure of, but it is a part of this triangle. I'm going to go ahead and call this angle theta, and that's what our goal is to find. Now, since I know all three side lengths and an angle, I can use law of sines or cosines. It really doesn't matter which one. However, remember law of sines, if this was going to be an obtuse angle, law of sines wouldn't give us that obtuse angle. I don't need to worry about that for this triangle because this is an obtuse angle. This one has to be acute, especially since we're in between north and east here. So I'm going to go ahead and use the law of sines. So I'll have the sine of theta divided by the side across from it, 80, will equal the sine of 120 divided by the side across from it, which is what we just found, which was 130. From here, we'll cross multiply, get the sine alone, take the inverse, and we'll end up getting our angle theta to be 32.204 degrees. Again, that's this angle right here, but we're looking for the entire angle, so we're going to have to add 20 degrees to our answer. And so our bearing for our resultant vector will end up being 52.204 degrees. Now we have all the information that we need for this resultant vector r.